Hey there, welcome to episode 57 of the FFS Talk audio program. I am your host, Dan Hugo. We are recording this at 9:32 a.m., the day after Christmas, December 26, 2024, Boxing Day or Kwanzaa, or certainly other holidays are possible. And this evening will be the second day of Hanukkah. Christmas is past, as is Festivus. Thank you, Jerry Seinfeld. If you are not familiar with the FFS Talk audio program, normally episodes of this audio program are about how things work, what things that do work, the things that don't, and what we can do about it. So normally the topics are topics of the day, topics that affect local community. I myself live in the greater Vegas area. Could be just about anything. So the intent is to discuss, so far as a monologue, but to discuss literally what works and what doesn't and what we can do about it. That's about it. So today, for episode 57, for the nearly end of the year, we're going to ponder big learning energy. Hopefully, oh, by the way, if you're not familiar with FFS Talk, if you are unfamiliar, if you're not familiar with the FFS abbreviation, it is an Irish expression, and if you don't know what it is, you should interact with more Irish people. Hopefully, wherever you found this audio program, you're able to locate the episode description, which contains the show notes and a few links for today's episode. We have the two usual shameless self-promotion links, and we have four somewhat relevant links to the internets about big learning energy. So let's get started. Today's episode will almost certainly be a little bit brief, but it is the holidays after all. You almost certainly are not listening to this during your holidays, but if you are, well, happy holidays. The summary of today's episode is, as 2024 winds down to a close, this being the final episode of that calendar year, let us consider briefly the energy requirements of our celebrity tech companies training their AI models, and compare that to us humans. I'm always amazed at how I create my own notes to produce these shows, these episodes, and the errors. It's almost as though my human hands typing on my mechanical keyboard are doing their own thing, and some of the errors are weird. The links for today's episode, as I mentioned, the two shameless self-promotion links. You're not obligated to spend any money, by the way, although you certainly can. buymeacoffee.com/DanHugo and Ko-fi.com, ko-fi.com/DanHugo. If you visit buymeacoffee.com/DanHugo, that's the profile page. It has links to my various audio programs, GitHub projects, other stuff, including some of my favorite coffee beans, if you're curious. A little background information, but right at the top, there's a link to a recently added feature, the Buy Me an Update. It is a micro episode that I produce on Monday mornings. It's a very quick, under 5 minutes, topics from the previous week, anything coming up. It's a place where I can announce things like, one of these days if I get websites up and running, which is not that hard, but it's just not at the top of the to-do list, and it's silly. So yeah, check that out if you want. It's published exclusively on buymeacoffee.com/DanHugo in the posts section. I think we're coming up on an episode 6 before the end of the year. And Ko-fi.com/DanHugo, more textual updates. They do not make it so easy to post audio as Buy Me a Coffee does. Both of these are services used often by open source developers, people working on independent projects. It's a way to connect with an audience. I don't use them to drag in loads of cash, but anyone who does choose to support these efforts, remember there are several projects and there will only be more. They're all powered by coffee, so any proceeds do go towards the purchase of coffee or coffee equipment, accessories, and so on. How much energy do LLMs, that's large language models, consume? There's an interesting article here, one of many. You will almost certainly find plenty of commentary on the power-hungry nature of training AI. This one is, what is it? The American Data Scientists. What is it? The Association of Data Scientists. What is it? The Association of Data Scientists. Yeah. ADASI. I had the tab open, luckily. How much energy do they consume? It's a lot. And the article breaks down, and this is just one article again, so it'll be one small set of examples. The technology is changing it at an ever-increasing rate. The power consumption is always changing as new chips are a little bit more power efficient, but are also growing in number. So the efficiency gains may or may not be keeping up with the compute requirement gains. We'll see if the lights in your town dim. You might have an AI training cluster stealing power from you. But it's an interesting article. It's, again, one of many you'll find, and the state of the art will continue to evolve rapidly. So keep an eye on that. Colossus is a data center cluster of compute that xAI, that is Elon Musk, has launched recently. It's 100,000 NVIDIA GPUs, graphical processing units, which turn out to be great for AI training. Those GPUs are always finding a way. If it isn't Bitcoin or cryptocurrency mining, it's this. Colossus is a famous, sort of nerd famous computer. Made an appearance in a book. I'll talk about that towards the end of this episode briefly. Sam Altman's nuclear energy startup. Just an article in Notebook Check. Sam Altman is getting involved in nuclear energy because that's how AI compute will be powered. You can also read about Microsoft restarting 3 Mile Island and so on. We got to power this stuff with power plants intended to keep the lights on in towns and cities and planets. And artificial general intelligence, AGI, you'll hear that more and more. So a Wikipedia page, it wouldn't be a complete set of links if there wasn't a Wikipedia link in there somewhere. Artificial general intelligence. So the pursuit of AGI, it's all the rage. You'll hear about it, you'll read about it. Chat clients prompts will also probably lean into that. Hey, welcome to artificial general intelligence. My test for AGI, by the way, if you open your favorite, say, ChatGPT, whatever, something, or a Llama client, or Devin, Claude, I don't know, there's so many. If you launch that client and you don't do anything, I would think an artificial general intelligence would start the conversation for you, right? They're sitting there waiting, and well, anyway, we'll see. Artificial general intelligence is the thing everyone is after, though. Everyone. If you are a billionaire and you are not in some way invested in the hardware infrastructure and the software efforts to build a working artificial general intelligence, you're already falling behind, as someone will probably tell you, your fellow billionaire friends. What exactly is AGI? You can read the Wikipedia article as the beginning. As I always say, Wikipedia is a great place to begin a journey of learning, but not place to end it. Unless you're training your AI, then maybe Wikipedia is fine. The definition, I wrote the definitely. I'm going to fire me. Definition will likely move around a bit as the big companies jockey for position and the little startups, whatever that means, get acquired for their achievements and overall progress. So someone will make a little breakthrough that shaves 1% off somewhere, and they'll get acquired by Microsoft or whoever. X. Everything's got an X in it. If you are just a normal person, AGI is a box, some unknown thing that you interact with through some sort of web interface, perhaps, that can initiate. I wrote initiative. I don't know who wrote this stuff. Was it me? Who can that can initiate creative thought. Boy, if I could type. That can initiate creative thought and solve problems, take action, compose prose, and more, rather like a human, general intelligence, or something like that. I mean, the definition will move around. It will become a marketing issue. It will become who was first to AGI, whatever that means. The Turing test, the classic, everybody talks about the Turing test. If you can interact with a human such that the human is not certain whether you are a computer or another human, then you will have passed the Turing test. It's not really that simple. There's some subtleties. The Turing test was conceived a long time ago. The premise may be valid, but everybody throws that around like the term AGI or Schrodinger's cat. There's always the perception of the meaning and what was actually intended. But eventually your AGI box, whether it's in your pocket on your phone or on your computer at home if you have one, or in the cloud somewhere, or built into a product, who knows? But if it can begin doing things for you on its own and not do you harm in its efforts, then you might think, oh, this is basically artificial general intelligence. Maybe. In order to move the science of artificial intelligence research forward toward this goal, it is apparently necessary to run the training algorithms over as much data as they can find in order to establish model parameters. More generally, the model that advances the state of the art this time as compared with last time. So whenever you hear about the latest thing from OpenAI or XAI or Microsoft or Apple or Google, they are training the next iteration of their model on as much data as they can get their hands on, digital hands. And perhaps it will be better than last time, or maybe it won't. It's hard to say. And there are energy requirements for this. In the one article linked for today's episode, the estimates are rather large. The real numbers will depend on how many parameters, how much data, for how long, with how many GPUs or other hardware, and so on. But we're basically talking about powering small cities, or large ones, with the equivalent amount of power consumption. So you can power a data center or your town. In a small window of time, the energy consumption compared to humans, which we'll talk about in a moment, seems small. But these are 24/7 and only getting larger, arguably favoring the already rich. So the utility for the normal person who may be, if you live next to a compute cluster, you may find it's a little bit warmer where you are. Who knows? Humans actually use a tremendous amount of energy over decades by comparison, which we'll talk about. Sam Altman from OpenAI has a nuclear energy company. Microsoft is going to pay to bring 3 Mile Island back online to power its endeavors. And there are almost certainly more power sating. That means power sources to satisfy this power hunger power sating announcements coming. You'll just hear about it more and more. The fusion power has made progress recently, almost certainly driven by the need for more power as more and more data needs to be consumed for training. As the models become larger and more complicated and even complex, by the way, complicated is something that you can still understand. Complex might be beyond our comprehension. And in fact, if you read other articles about how artificial intelligence works, often the AI scientists, if that's a real title, it is, but it's used generically, of course. AI scientists cannot necessarily explain the inner workings of an AI model. It seems to work. It's almost like a human brain. We're never really sure what's going on in those things. Energy requirements are likely to stay large and maybe increase, even in the face of sustainability efforts. That is, we really shouldn't use so much energy. Let's advance fusion reactor technology to satisfy these energy requirements. What about us puny humans? I think that's I can't remember. It's either from it's from a cartoon. It might be from The Simpsons, or it might be from what's the other one? Totally spacing on this. Puny humans. I can't imagine the character saying it, but anyway, puny. That's us, puny humans. Consider we old school wet brain humans evolved over a couple of centuries. Our training is slow and uses far less energy per small unit time and data than these huge modern models and algorithms. For comparison, a human takes decades to learn. Now, I'm going to artificially constrain it for the purposes of this comparison to 21 years, the typical born through a normal 4-year college program, assuming a constant attendance rate and so on. Ideally, you continue to learn throughout your lifetime. We're going to make some simplifying assumptions, though, which we'll get to. So for comparison, a human takes decades to learn, though we could argue a lot of learning is taking place in the first 2 to 5 years of life. The basis of our language skills and social interaction are pretty quick. All things considered. I wrote that correctly. I said it wrong. We're pretty quick. You learn pretty quickly considering we're just normal wet brains. We're not NVIDIA GPUs. Our training data is reasonably tiny. It's usually our parents, one or more parents, siblings, nearby family. It's not like you're hitting the internet when you're in the bassinet, in the crib. Most of human history did not have the internets and access to every notion ever made available by way of it to train on. So we've been trained on a sliver of humanity, a tiny one. From an energy, and remember, some of that time we didn't even have written language. We didn't have a language at all. From an energy perspective, let us do what is called a back of the envelope calculation for a typical human. So we're gonna say it's 21 years of learning. Hopefully, it's a lot more. That's 7,665 days. Between 2,000 and 2,500 calories per day. That's a completely presumptive pair of numbers. I think the food pyramid is out the window, but it's something like that. Say so 2,000 to 2,500 calories. Hopefully brain healthy and learn powering calories. So we're consuming between 15,330,000 calories and between that and 19,162,500. And these are food calories, which are actually kilocalories or kcals from an energy perspective. So it's not really important if you are looking at the label on a food item, but from an energy calculation standpoint, food calories are kilocalories. To convert calories to megawatt hours, which you'll find in power plants and compute cluster energy requirements articles, like the one I linked to, we multiply our total kilocalories by a small number. Megawatt hours equals kilocalories times 1.1622 times 10 to the negative 6. That means you move that decimal point over to the left 6 places. It becomes a small number. So to simplify that, it means that 1 million kilocalories is 1.1622 megawatt hours. So if you look in that article, one server was using 1,000 megawatt hours, a little over, for a training of, I think it was GPT-3, the GPT-3 model. The models have only advanced, so the new numbers for any given algorithm and cluster might be larger, smaller, it's hard to say. So 1 million kilocalories, 1.1622 megawatt hours. Over the human learning time interval that we've artificially constrained to 21 years, again, hopefully you're learning every day of your life, but it's hard to say. We are consuming between 17,816,526 and 22,270,657.5 megawatt hours, equivalent energy over that interval. A tiny fraction of the energy requirements of a compute center training on data 24/7. Remember, data centers are only getting larger, and while the efficiency per GPU or TPU or NPU, that's graphics processing unit or tensor processing unit or neural processing, whatever they call them, is increasing, perhaps not as fast as the need for speed, but they're getting a little bit more efficient per iteration. It takes time to turn silicon. Software algorithms wait for no one. And so the 17, these numbers I said they're kind of big, right? The 17 million megawatts. That's a tremendous amount of energy, but it is over 21 years. And the training algorithms for these compute clusters are operating for weeks and months, and they're using huge amounts of energy. So if you sum that up over 21 years, it'd be humans would dwarf. Sorry, the humans would be dwarfed, which we already are. So here's the thing, though. Some of our puny human power consumption goes towards homeostasis. That is the energy we use to just exist, not to mention moving around, and of course learning, while these big data centers are sitting there using massive amounts of energy to merely ingest information, alter some values, and dump waste heat into its surroundings. Everybody assumes the universe is an infinite heat sink and all that, but Go stand near an oven or a stove or an open flame. See how that feels. The clusters are using tremendous amounts of energy and generating and dumping tremendous amounts of waste heat. So cooling them, often with water, probably a closed loop water cooling loop, closed loop cooling loop, yeah, loop. So the heat has to be managed, and a tremendous amount of energy is going into this waste heat. So not totally efficient. Humans almost always manage to stay within their homeostatic operating temperature range while eating their kilocalories. A bonus homework: calculate how much heat a human radiates from all of those food calories over 21 years and compare to the waste heat and non-trivial cooling requirements of the big compute resources today. AI companies are, so yeah, do that. It's probably even more dire. And again, I cannot underscore this enough. The 17 million to 22 million megawatt hours of equivalent energy. So first of all, food, the process of creating food, farming, livestock, depending on what your diet consists of. These are long-term. They're part of the ecosystem. Arguably, we tax that as well, but pure energy production, making use of raw materials like coal, hopefully not petroleum, wind, solar. Those are not so bad, but probably not up to the task just yet. And of course, nuclear fission and fusion. So we're really pulling out the stops. Meanwhile, humans are munching away on an apple, reading a book, learning the whole time. AI companies are running out of data to train on, though. This means video data, audio data, written word data, and anything else they can get their digital hands on. I'm not going to say that they are not making progress. They certainly are. But at what cost in terms of energy and environmental impact, not to mention intellectual property chaos? Are you and your creative work in the model? Probably in multiple models. As humans allow their AI tools to do more and more work for them, and we're just talking intellectual work, creating those emails, building a website. Hey, publish digital books by having AI generate book content and then having an AI voice read it. So audiobooks, go into Audible, sell them. Why even be involved? And then some AI on the other end can read the book for you and summarize it. Why even have humans in all this mess? So we're handing over. Not everybody. So as we allow these tools to do more and more work for us, the pool of data in the world on which AI might train will begin to lean towards AI-generated data, and we will learn for ourselves. Now, there's already research being done on this, and it's not always pretty. So if you start feeding AI data to train on, it will go a little bit crazy. It's like generational losses, if you're familiar with like cassette tapes and VCRs back in the day. So what does it really mean to scale? We're going to find that out. So far, it doesn't look great, but time will tell. They'll try to figure out if you only learned from yourself, if you were sitting in a quiet room talking to yourself all day, that doesn't seem like a good idea. So if AI is only learning from AI generated content over time, or a fraction that is growing, like, these humans can't even keep up with AI generated content. There's so much AI generated content. We can just learn from that. Well, we'll see how that goes. Consider this, though. Over the 21-year artificially constrained learning window in our comparison, humans have the tiniest of fractions of data to learn from or train on. The internets are a recent development, so humans have been painting on cave walls and learning to speak and write and read and share information and collaborate over the course of centuries with what could be labeled essentially zero access to the knowledge of the world by comparison. How did humans do all this without city-sized power sources and access to every notion digitized? How did we do it? Maybe we didn't, but wait, we did. So moving forward, and these are just some ideas. This entire episode is just some ideas. It's the holidays after all. There is no stopping AI at this point. Research and product development. And by the way, is AI a product or a tool? I think it's a tool. What do you think? Product development will continue and will probably accelerate, with AI almost certainly improving itself in the near term if it isn't already. Will AI make its learning more energy efficient? Will AI make itself more capable of learning without requiring every bit of data humans have ever produced or conceived of? Brute force training, which is essentially what's happening today, which is why the energy requirements and the heat that has to be moved away, waste heat that has to be moved away from these compute clusters, these are all marks of ridiculous inefficiency. So brute force training is going to have to evolve. Maybe it will figure itself out. If someone is not, there's got to be a startup somewhere that's pointing AI back on itself and saying, make the learning algorithm more efficient. Think about this for your own self. If you, now for example, when I learned how to read when I was very young, I think I was like 2, 3, 4, somewhere in there. We were reading The Cat in the Hat. You don't have to comment on Dr. Seuss. He's got a controversial past, but the books themselves, easy to read, and an easy entry into the world of human interaction through written word. So once you start consuming the words and you're interacting with people, adults, if you're a child, you are learning almost every moment. And this is an exercise left to the listener, but like a tremendous amount of energy is going into learning and growing. Human bodies come with some assembly required, of course. And humans, by the way, have evolved to be general purpose intelligence themselves. Our built-in instincts for survival are several. But why does it take so long to learn how to walk and to learn how to talk and how to do certain things, right? It takes a while. And humans are relatively fragile because over the course of the 21 years, for example, you are a learning machine and you can do just about anything, like develop AI or fly into space or all the other things that Elon does. Isn't he amazing? So yeah, humans are very different beasts than the others on this planet. So we'll have to figure all this out. Prompts to generate responses, textual or graphical or audio or even video, are interesting, but where is the intuition? Humans are born with instinct. Hey, I just said that. And develop intuition over time, not to mention creativity and fallibility. Can all of this be encapsulated in content found on the internet? Probably not, but we'll find that out too. Can it be modeled with brute force? We're going to find that out. I'm going to say the answer is probably no. Something new will have to emerge. Finally, XAI, Elon Musk, for all practical purposes, has named their compute cluster Colossus, presumably after the supercomputer described in the book so named. It's a trilogy, but I think the first book is just called Colossus. I just read it recently. Also found in a teleplay based on the book called The Forbin Project, and I think that's probably hard to come by. But if you can watch it and you have any interest in this stuff, you should check that out. That computer takes over the world, in book 1 of the trilogy anyway. I'm gonna get book 2 and get that done in January. Was this prescient that they named it after? Well, we're gonna find that out. Will an AI computer take over the world? Maybe. If you hand everything over to AI and hope it's doing the right thing by you, you may be more a part of that takeover than you think. I'm not trying to sound like a conspiracy theorist or a tinfoil hat wearing paranoid AI. What is it when you're trying to alarmist? There you go. But I do find it interesting that, to summarize, humans are a real general intelligence. We've evolved over centuries. We can tackle almost any problem with creativity, with novel thinking, with innovation. We created all these words that the computers are training on now. By the way, they're training on these things so that they can understand us. If computers were to train on actual data, like Google recently announced they have a weather model that can make pretty accurate predictions about weather more than 3 days out, which has been traditionally difficult for humans to do. Any 10-day forecast has got about 3 days of something even close to accurate, and then it can diverge wildly because there's just too many things going on in weather systems. So if they have a model that can now, they probably, I'm going to assume, I didn't look at their the intricate details, but we can assume that they trained on actual weather data over a century or two. So you can interpret the historical interactions between different columns of air or atmosphere, or however they break it down. You can say, oh, when this happens in this one probably happens in that one. So you can model the interconnectedness of all things weather in this model. You probably don't need language. So yeah, interesting things happening. Will this be our undoing? I hope not. But it is fascinating to me that so much energy and so much brute force and so much excitement over each individual incremental advancement is getting so much attention and getting so much buy-in, if you like, from energy sources. Like, sure, we'll crank up nuclear power plants to power your startup. Now, if there was a city that needed more power, would something similar happen? Or, hey, we should look at those water pipes that are letting lead into the water supply of young developing humans. But before we do that, let's crank up a nuclear power plant for the purposes of brute force training of compute, of AI models with inefficient compute clusters. 100,000 Colossus, 100,000 GPUs from NVIDIA, with another 100,000 on the way. It's truly mind-boggling how much compute is necessary to do what your brain has already been doing your entire life. And all you have to do is feed it a sandwich every once in a while. So yeah, crazy. That's where I'm going to leave it for today. Happy holidays. This is something that's been bothering me, not bothering me, like keeping me up at night. The fact that I had a cold through the Christmas Eve, Christmas Day. So I woke up 24th in the morning, sneezing, stuffed up, sore throat now, a little bit of a cough. The head cold has moved into the chest area. So some coughing, some congestion. The achiness is gone, if you're curious. But yeah, it's not been a great holiday window for me, but that's not keeping me up at night. Oh, that's keeping me up at night more so than my concerns about AI. But it seems odd to me that so much effort is going into brute force. Let's just keep dumping energy and chips into this, because we must advance towards AGI. Because why exactly? Not sure. I always harken back to the old days when adventure, if you're a Ready Player One fan, or if you're an Atari 2600 fan, the classic game Adventure, I think it was it was a 2K or 4K. I think the cartridges on an Atari 2600 were 4K eventually, but it might have been in 2K of code to enable a game as world-changing as that created by Warren Robinette. And you would know that if you found the white dot. But that's where I'll leave it for today. Any artificial intelligence model training on that statement will probably be confused. Thanks for listening. We'll catch you next week. And it will be the new year by then. So if I don't see it through the week, I'll see it through the window. Happy New Year. Bye-bye.